Okay, so we're going to be solving separable differential equations given an initial condition. So let's just go with a little review. First off, when you have an integral like x squared dx, it's called an indefinite integral because you haven't been given any limits of integration. So that means that when you integrate it, you have to put plus c. And we don't know what that constant is. And I can put y equals here. They have to give you an initial condition. Okay, so let's suppose I have my original equation, y equals x squared plus 3. Now the derivative is y prime equals 2x. Or it could have been y is equal to x squared minus 5, and the derivative is still also y prime equals 2x. So it doesn't matter what the constant is, I end up with the same derivative, but the problem is that I don't know what the constant was for that specific equation, and that's when they have to give you the initial condition. So let's suppose I give you y prime equals 2x, and I ask you to find y, okay, and I give you a little bit more information, okay, so I give you the derivative, and I give you a point on the curve. So in the scenario, the point is y equals 4 when x equals 1. So now when I find the antiderivative, I can plug in 4 for y and 1 for x, and I can solve for c. And I find that the constant was c, the constant c was 3, and then I can write the original equation. This is kind of what we're going to be doing. All right. So it's called initial value problem, and this is called a differential equation, and it becomes an initial value problem once I give you the initial condition. Okay, so this is what it's going to look like. A lot of times they're going to write, instead of y prime, they're going to write dy dx equals 2x over y. So what we're going to do is we're going to use this initial condition later. First, I'm going to do what's called separation of variables. Okay, typically these questions are worth 6 points on the AP exam, and you can pick up a lot of points just by doing simple things like separating the variables. Okay, so that separating the variables means that you get all of your y terms and all your x terms on one side. So dy is still considered a y term, and so is dx. So I want dx on the same side with all my x's and dy on the same side with all my y's. So I cross multiply. Okay, I always say that cross multiplying will save your life. So here I am saving my life by cross multiplying. And then sometimes after cross multiplying, you still have to shuffle some of the terms around to get your y's and x's on the same side, but the cross multiplying is the first step. In this case, once I cross multiply, I'm good. And then I'm going to integrate both sides. So I'm going to integrate y dy and 2x dx. Okay, so separating the variables, I believe that just gets you 1 point, and then we're going to integrate both sides. And pretend like you're integrating x dx, because I'm integrating with respect to y, so the antiderivative of y is going to be reverse power rule, y squared over 2, and then the antiderivative for 2x is going to be x squared. Now, just by convention, we usually just put the plus c on the side of the x term, because once you're here, you're not done, because you need to, number one, get y by itself, and number two, use that initial condition so that you can plug in for c. So doing this gets you another, I believe, 2 points. It's like 1 point. This is like another 2 points. So what I do now is from here, and this is just a matter of personal preference. I could totally solve for y and get y by itself here and then use my initial condition. But I prefer to just plug in my initial condition right away. So this is x, so x is 0 and y is 2. So everywhere there's an x, I'm going to plug in 0. Everywhere there's a y, I'm going to plug in 2. And then I can go ahead and solve for c by following the order of operations. So this ends up being 4, and I have, I'm sorry, not 4, 2. So c equals 2. And now I can go back here, okay, and write my equation. So using your initial condition gets you about another point or 2 to solve for your constant c. And the last point comes from writing up your final equation, solving for y by itself. So at this point, I've already got 5 out of 6 5 out of the 6 possible points that this is typically worth on the AP exam. So you can see you get a lot of points. Now I'm going to get y by itself. So I multiply both sides by 2. 2's cancel over here. And I distribute. And y squared is equal to 2 squared plus 4. And the only way to get rid of the square is to do the opposite, which is to square root. But you know when you square root anything that has been squared, you have to put plus or minus. Okay. So this is where I like to check again. So one of the misconceptions is, well, since f of 0 has to equal positive 2, I got to make sure I keep the positive. Well, always just check. So I'm going to check and make sure that I am going to, in fact, keep the positive version. And the reason I'm saying that is because later on I'm going to give you an example where we have f of 0 equals 0. And in that case, 0 is neither positive nor negative. So you want to make sure you pick the correct one. So if 2 is equal to plus or minus 2 times 0 squared plus 4, and I know this seems rather obvious, but just humor me. The only way I'm going to get positive 2 is if I end up with the positive square root of 4, not the negative square root of 4. So that's why when I write my final equation, it's radical 2x squared plus 4.